Good morning, everyone. Welcome to Contemporary Issues Sunday School class. Nice to have you here today. We are pleased to have Mr. Ron Puning with us again as our professional speaker and presenter on all topics, but especially on this area of expertise for him, space. And he was going to talk about UFOs, but I noticed in
We'll
here.
touch on it.
Will we touch on it a little bit?
Yeah,
Okay,
yeah.
but you didn't really have any slides on that because there's not much really new in the UFO world, is there? I mean, there's been things released and the government's promising, oh, we're going to release all this and look into what the real story is, but nothing seems to really come of that yet.
Yeah, we'll touch on.
Good.
on
Okay,
a couple
okay.
slides.
Before we get started, if we have any first-time visitors, I'm Steve, the leader, and I want to welcome Spencer in the front row, Linda Harmon's grandson.
Yeah,
Spencer.
yeah.
And he is studying aerospace. Where at, Spencer?
Purdue University.
Purdue University.
Noisemaker.
Wonderful.
Yeah,
Boilermaker. Wonderful. Well, you came to visit on the right day when we're talking about space and discoveries today. So, welcome to our Zoomers. Please mute yourself when you're not speaking. In the lower left corner of your screen, click the audio button. And we are recording this for future playback using our little owl device here. And do we have any other announcements? Any things coming up besides our
September 12th.
reminder of our fall picnic, September 12th?
Details will be coming.
More details coming, but it'll be fun. The Coven Park. Okay. All right, most of us know Ron, but let me tell a little bit about Ron too. Retired engineer who worked on nuclear reactors in the gaseous diffusion department.
yeah, isotope separation.
Isotope separation.
Yeah.
Yes. And also, most recently, before you retired, working on the Webb telescope with software engineering and quality control of the
Yep.
software. Your team
Processes.
looked over the quality processes of the Webb telescope, which has done more photography, advances in photography than it ever was possible before, right? So he wrote his own book.
Yeah. Buy the book. Even if you can't read, this book has one of the greatest sets of pictures, colored pictures that I have ever seen. And it's affordable. I think you can get it for $35 maybe.
Very
Maybe it's
good.
gone up a little bit, but
Want to pass it
whatever.
around?
We'll pass it around.
Okay.
Are you one of the optics?
Of course not.
Okay. And what else was I going to mention? I think that's about it. Oh, one of your slides I noticed is the theological implications of recent discoveries. And so Ron will bring that into the discussion with all of the planets out there and what's the possibility for more life being discovered in the universe these days than it was in the past? And if it was, what's the theological implication? How would God interact with different alien beings than he would with us? Would Jesus visit them in the same way that he visited us? What would the relationship be? We could speculate on that.
Steve, this is a family thing, aerospace. Our son, our granddaughter and her partner, they're all aerospace, so it flows through.
Your son and granddaughter, everybody in the family's in aerospace, a spacey family. Okay. We're glad for it. All righty, I'm gonna stop babbling.
Okay,
Welcome, Ron.
okay, thanks a lot. Let's go back. Let's get the slides up. Let's go back to the first slide. I'll start with a joke. A guy comes home from a parent-teacher conference and says, you know, I'm convinced the teacher thinks our son should be an aerospace engineer or something.
He's gifted.
And the guy says, well, how do you come to that conclusion from the discussion? She said, the only thing your son's good at is taking up air and breathing air and taking up space. So Hopefully that's not me. Here we go. All right, on this very opening slide, let's go back one. Yeah. If you look at the Old Testament, it pictures the universe, shall we call it, pretty simplistic. They thought of Earth, thought of clouds above and heaven being clouds up in the far reaches. They weren't quite sure what stars were. They thought maybe there were giant candles or something. And then, of course, down below was Sheol and the pillars of the earth, and that kind of stuff. But there really wasn't, it was pretty simplistic. And the Bible, of course, gives no indication whatever of the true reality of the universe, which is, just looking at a segment of it, there is a depiction of the Milky Way galaxy, and they name the arms. The arms, they have different names to them. And our sun is stuck in one of those spiral arms there of a galaxy. And the galaxy is multi light years across. Okay, next one. You've read the cartoons, one of my favorite ones, Calvin and Hobbes. Does anybody remember the Calvin and Hobbes? I used to look forward to that every morning.
One for those in the back that can't read it.
Okay.
Would you read it?
The tiger saying, "What would you call the creation of the universe?" Calvin says, "That's the horrendous space kablooey." And then over there is a little more humor where Calvin is saying, "Sometimes I think the surest sign that intelligent life exists elsewhere in the universe is that none of it has tried to contact us." Next. And of course, I'm a big fan of The Far Side.
Yeah.
And this shows some aliens who have stopped at Andy's Gas and Go. And the station attendants looking at the map and saying, "Shoot, you not only have got the wrong planet, you got the wrong solar system." I mean, a wrong planet I can understand, but a whole solar system? Okay, which brings us to mention of Neil deGrasse's latest book. He, of course, has at least a dozen very excellent books out there. But his latest one that made the bestseller list just a month or so ago is one you could read in about 2 sittings. It's simply titled, "Take Me to Your Leader." Okay, next one. All right. So if we're learning anything from the latest Hubble and James Webb Space Telescope and others, they're not the only ones out there. They're putting some even more dedicated telescopes to look for exoplanets, look for solar emissions, specialized
Hey,
telescopes.
Dave,
Yeah.
are you sure you don't want to watch this? It's really interesting. We can always go early to the golf.
You need to mute. Well, that's better than hearing, "You gotta listen to this guy's boring the bleep out of him." Oh, well. Okay.
I was able to mute them. Go ahead.
Okay. All right. If we get nothing out of this, this lesson helps you start to realize that symbol up there that I put, which is, it's like somebody knocked over the number 8.
Yeah.
For those who have taken calculus and trig, that's the symbol for infinity.
Oh.
And of course, if we look at the universe and where we are, we start at the very bottom. String theory is about as far down as we've reached, and we'll get into that a little more in this lesson. We step up a level to subatomic particles, such as quarks, muons, other named subatomic particles. Then we move up to atoms, and of course, we didn't really know the details of atoms until around 1900, 1910-ish. Then we move up to atoms combining to make molecules. Then we move up to solid, seemingly solid objects. They're not. We're mostly empty space. Planets, suns, solar systems, galaxies, universes. And we'll talk today a bit about multiverses. And we've got some in your handouts. In fact, in your handout today is one of the highest concepts of a multi-universe. They think our universe is like a kind of like a slice of bread, maybe almost infinitely large, but we think there's stacks of these brains, not things inside, spelled BRANES, that are stacked. And you can look at the handout there, it'll give you some ideas. So we're also on so we keep going up and up and up on the high end universe, multi-universes. And Lord knows what beyond that, multi-dimensions, multi-universes. We go way down to the other end. We've broken the quarks into what we think are maybe little strings, but they suspect they are so small, like 3 or 4 orders of magnitude smaller than an electron microscope can see. So they're so small we can't, our human senses and our abilities, our instruments cannot detect them. But let's jump on. Looking at the galaxies, there's of course many kinds of galaxies, and if you look at the book being passed around, it's got some phenomenal pictures of galaxies. This is one of the deep sky images taken by Hubble, predecessor of James Webb, but it focused on one tiny sector of the sky. In fact, this sector blown up is so small that if you held a grain of sand at arm's length, it would be what was hidden behind that grain of sand at arm's length. And the blown up, it's all that. So it starts to give us an idea of how absolutely there are a million, trillions of galaxies of different kinds. And the more we look, the more awesome it gets. Next slide. Again, it blows our mind. The observable universe, that's just stuff that since the beginning of the Big Bang, the light has had time to travel to us. That's all we can see. Anything beyond that is it has the light hasn't gotten to us yet. But they think right now just the observable universe is estimated to have 2 trillion galaxies, not stars, galaxies. And so they say that's enough for 200 sextillion stars. That's 20 times 10 to the 23rd. Planets, look at that number. That's a 3 with 26 trailing zeros. That's how many planets there are. And they estimate that's only what we can sort of see and estimate. There's more than that. As of June of this year, scientists confirmed the discovery of almost 6,300 exoplanets, planets that we can see. Often we detect them by they're passing in front of their star and slightly dimming the starlight coming from a star on a periodic basis as the planets go around.
What's the difference between a planet and an exoplanet?
Exoplanets are not the ones in our solar system. So other ones. But there's it looks like there's with all those stars, and I think what's the estimate of how many planets per star? Not every star has planets, but they're just phenomenal numbers of them. Just phenomenal numbers. And I've drawn a picture there. Remember that ad on drugs? This is your brain on drugs, and they showed the eggs in the skillet. And I've got it also in that picture, the smoke coming up out of the computer. Yeah, crunch it down. Yeah, put it back to original size. I saw smoke coming out of the computer. Somehow that's how I feel when I start looking at how awesome the universe is. I'm reading a book, and I'll have to read it about 10 more times. This might be the most mind-blowing book I've ever picked up. It's simply titled The Hidden Reality. And he does a really good job of explaining parallel universes, brains, multiverses, altered dimensions, the concept of infinity. Our brains can't grasp infinity. And just like we can't grasp subatomic stuff that's so small, we can't even conceive of something that small. We can't conceive on the other end something that's infinitely large. What are some of the concepts of a multiverse? Well, we know our universe is expanding. It's something called the cosmological constant. And the size, if we took the football stadium downtown and took that volume within that and encapsulated it out in space, we just took a volume, we're out a volume out in space. We think there's enough energy in that football field dimension for a flea kick. The energy of a flea kicking,
Oh,
that energy. You say, well, that's not very much energy spread over a football field volume. But if you take the volume of the entire universe, there's suddenly a phenomenal amount of energy. So our concepts of multiverses, we think there's probably multiverses, and they're probably like a bunch of boiling froth bubbles that are growing, and we're in one of them. And
that's weird.
Ron,
it blows our minds.
just a quick comment. I remember one of my favorite images that I learned was the thought about the Big Bang possibly having started because two bubble universes banged together and our universe popped out of that collision. Isn't that an interesting
More
way
than I've
to
heard.
visualize it? That the energy from two banging together popped out, gave birth to our universe.
Think of it, next time you're boiling water, watch those little air bubbles come up. That's kind of like a universe creation. Yeah. Some pictures, the first 2 pages of your handout show some concepts, artist creations, of course. Okay. Next one. Yeah, there's those brain. The brain multiverse version suggests our universe exists on a membrane which floats in a higher dimension, which is called the bulk. And in the bulk, there are other membranes with their other own universes. These universes can interact, and when they collide, energy produced is more than enough to give rise to a Big Bang. The brains float near each other in the bulk, and every few trillion years, attracted by gravity or some other force, collide. That's nonsense. Okay, let's jump over. How do we visualize things that are super small? Suppose there's a soda straw on the New York skyline that's reaching up out of a building. We look at it from 3 miles away, and I'm not even sure our eyes could see a soda straw, but it would certainly look like just a line. But if we explode it, we see that it's got more dimensions than that soda straw. It's got a radial coordinate and longitude and thickness to the straw wall and stuff like that. And in a way, we think our universe has some stuff so small that it's there, but we just can't see it. It's beyond our conceptual ability to see it. Another way of imagining it is if you're flying a airplane over the Great Salt Lake that's covered with carpeting, thick plush carpeting, all you see is what looks like a level surface. But if you dig down and go into the carpet, you find out there's all these tangled threads within it. Next slide. Some think that if we dug down in the super small dimension, there's maybe like 11 dimensions, and they're maybe stacked in some kind of Rubik's Cube array with these weird odd shapes. So there's all kinds of suspicion as to what's going on in the really low level. And they think there's at least 11 dimensions. We think of the X, Y, and Z coordinates and time, and they think there's got to be a lot more, particularly down at the really small, can't see, can't hardly even imagine level. Next one. And then they think that the quarks, these are the particles that come together to make up like a neutron or a proton. They think if you dig it down into a quark, it can be subdivided into these strings, these super like dental floss strings. They think they vibrate like playing a trumpet or something at different frequencies, and they have different dimensional energy, shake vibration, spin vibration, turning forces, and they're so small that we can't measure them. Go ahead.
The scientists who make up these theories, not who discover or create the theories, are those theoretical physicists?
Yeah.
Okay.
Yeah.
Okay.
Yeah, quantum physics is the.
And this
the
is what
realm.
they do all day long.
Yeah, yeah, and actually, the mathematics are really what's guiding people into this. Because these concepts mathematically come together.
Hmm.
The mathematics suggest that this is there, even if we can't see it. Go ahead.
You say discover it, or do we invent these ideas? Are these theoretical scientists imagining this stuff, or are they finding any evidence for it? How do these ideas?
Okay.
come up?
Yeah.
The answer is
Yes.
we don't know if there's strings. Not all the scientists believe there's strings. It's yeah. However, the mathematics trying to come together with a grand scheme of mathematics to put quantum physics together suggests that we're missing something, an understanding gravity, and this is a possible explanation for what might be happening. And the mathematics say that this would work and explain it. But you're right. We don't know this. We do know there are quarks, up quarks, down quarks, strange quarks. They're really, that's the name of
We
them.
have seen those. Is that right?
I don't know. I don't think an electron microscope is it, but they've detected them through other collisions.
Yeah, we've detected them, but we can't see them.
Yeah, I want to give credit where credit's due here. Spencer here is at Purdue, and he's got a degree in astrophysics, and he's about to get his master's in aerospace engineering.
Can I ask you?
And there's some real doubt whether I should be the person in the chair today.
This might be a question, Spencer. As a former teacher of the basics of astronomy, I've always wondered, after getting my students the basics, again, this might be a special question. I've always wondered why the universe isn't just expanding, but it's accelerating in its expansion. And the short answer I always thought was dark energy. But what's the latest, Spencer, is what I want.
I would say the latest is that we still don't know. It's an open question, I would say, that one that a lot of people are working on, but that kind of question is the reason why scientists have come up with or invented the idea of dark energy or dark matter is like and it's kind of similar to the strings. You see a phenomena and then you try and come up with a theory that would create what you see in person. So you can't detect them or see any of these things, but the math kind of leads you to suggest that a theory like that would show up in the way that you see it.
Very good. All right.
Good. Keith had a question and then Leanne.
Strong mathematics.
Oh,
Yeah, Frank, hand him the microphone, please. Thank you. Keith, straight up.
That was
over
my
from
question about how that relates to dark matter. So you answered them. Kind of, we don't
Okay.
know.
Yeah, we're still grasping to understand what dark energy and dark matter are two different things. Yeah. Okay.
Hang on
Let's
just
get
a
back.
second.
Oh, go ahead.
Leanne had a question.
Fireworks.
Universities do we know that are studying this phenomenon?
How many universities?
Yeah,
University.
are all,
Well, any university that has an astronomy department,
oh, okay.
a lot of or major science departments.
So
Of course.
That's a lot then.
Yeah, and maybe the center of excellence might be the CERN accelerator out there on the Swiss-French border. And they're going to enlarge that, I believe. But they're colliding particles. And just in the last 2 decades, they have discovered evidence through particle collisions. They've confirmed there is such a thing as a Higgs boson. And I think we've got some graviton evidence and some other subatomic particles that are now being discovered.
Smaller than quarks,
Not-
Similar scale, I would say.
similar scale.
Given that,
Okay.
yeah.
Okay, Judy has
I was
comment
just
too.
gonna say, Spencer, my grandson just got an aeronautical engineering degree from Florida. Going to work for Lockheed Martin tomorrow.
Congratulations to him.
Oh,
Okay. Let's move along. Of course, I want to give most of the credit to comic books. There's an image I took from a comic book when I read as a kid in 1961 that showed Green Lantern going down to a subatomic world.
oh,
So thank goodness for comic books. I wouldn't be an engineer.
there's many engineers.
Okay. Of course, the one that really blows my mind, and I'm at a loss to explain, is something they call quantum entanglement, where two particles instantly affect each other regardless of time or distance. And they can be entangled even if they don't exist at the same time. And I don't even want to try to explain this one. This one totally fries my brain. But if you want to really challenge your mind, start reading about quantum entanglement. Okay, next one. Yeah, there's expanding universe, how we started with just a tiny sand-like less than concentration of energy and exploded in a matter of microseconds. Most of the big stuff happened, and then moving on in time to where we are today in our universe. So that's a pretty good study. Next one. As I mentioned, our Milky Way, there's a mention of some of the names of the arms of the Milky Way. And the sun is in the Orion arm, it looks like, yeah. Okay, next one.
Oh, they're not in a different house, like the song said.
The House of the Rising Sun.
Good, that's a good one. Okay. All right. Of course, looking back on the Earth through evolution, we can see as we march back in time, our evolutionary path back to 2.5 million years ago, where the first primitive bacteria emerged, single cell, multi-cell organisms, and on up through time. There's also a tree of life on the bullet board over there that shows some of the diversity of species and how all the species are interrelated, how we can find DNA strings, pieces in our DNA that go all the way down to things as common as the fruit fly and stuff like that. Okay, next one.
Northern.
I have a quick question. You had a good race. As an evangelical as a kid. I honestly had a pastor say that the world is 6,000 years old. So I'm wondering, have you ever had someone say this is a load of hooey?
I stand amazed in today's world. People ignore facts and just throw out facts quickly and just believe what they want to believe.
They create their own facts.
Yeah, and certainly that defect permeates theology and politics. Phenomenal. Yeah, facts don't count anymore.
Alternate fact.
Alternate facts.
Alternate.
Okay. Quick mention of life's chemical building blocks. The building blocks of life are sugars, amino acids, nucleotides, lipids, and they have found all 5 of the building blocks of DNA on an asteroid. Okay, out there in space. So the ingredients for life are out there. Next one. In fact, the asteroid Bennu was sampled. NASA sent a mission called the OSIRIS-REx that went out and actually directly collected some samples, and they found the chemical building blocks of life including the amino acids, the nucleobases for DNA, RNA, the sugars. There's Pepsi and Coke everywhere. Directly in space. These uncontaminated samples they brought back about 9 ounces worth showed how the early solar system had the chemical factory for life's raw ingredients.
Cool.
Pretty neat, huh? Okay. Okay, we won't get into this. Why are we here? Rick Warren's The Purpose-Driven Life opens with "It's not about you." This appeals to the feeling that you're confused and overwhelmed with life challenges and offers a quick solution. It's not about you, it's about God. Other possibilities include we could be spiritually inclined without belonging to a traditional organized religion. We could be devoted to a culture, nation, or family. We could be devoted to meaning based on scientific grounds. Naturalism says it's up to you and every other person to create meaning and purpose for ourselves.
Yeah.
Neil deGrasse Tyson says, "For me, I'm driven by the two main philosophies: know more today about the world than I knew yesterday, and lessen the suffering of others." You'd be surprised how far that gets us. Next one. Okay. All right, what to expect in life forms. If life forms are going to be found elsewhere, I'm hoping we find some in our solar system, although I don't expect them to be advanced life forms. But I'd be tickled to death if we could get some bacteria or some at least primitive life discovered on like Enceladus, a picture of which is in your handout.
Page 4.
Yeah, page 4 specifically shows some geysers that are coming up off of Enceladus. That is a moon of Saturn. And the Cassini probe, I think, got the first pictures, maybe the only pictures of these. They jet hundreds of miles into the sky, and they think there's maybe a subterranean ocean on Enceladus. And there's a lot of excitement about another moon of Saturn, Titan, and some of the moons of Jupiter show promise. So if there's a regret that I'm going to live a finite life, I'd love to be as young as Spencer or even another generation younger and see what we're going to discover in the next 100, 200 years. What to expect in life forms. Neil deGrasse Tyson, in his book, Take Me to Your Leader, points out that we seem to think that aliens that are probably out there are going to look quite a bit like us. But he said there's no good reason to expect that. Every time you see a science fi movie, they usually have arms, legs, head. They're usually green. They have two big bug eyes, oversized head. But he says, if you look at just the diversity of the species on Earth, we should expect, if there's life forms out there, there should be even a greater array of life form and styles. We shouldn't expect them to look like us. Next slide. Yeah, of course, having read the great Green Lantern comic book, 1961, they had Green Lanterns on other planets and stuff, and they were alien life forms. And the comic book artist came up with some other expectations of what life forms might look like on other planets. Again, thank you, comic books, for giving me an open mind. Next one.
Makes sense.
I love this one. A couple cartoons are appropriate. The one alien saying to another, "Take me to your stove. You idiot, give me that book." And then here's another one. Inadvertently, Roy dooms the entire Earth to annihilation when, in an attempt to be friends, he seizes the alien leader by the head and shakes vigorously. Okay, let's shrink down and get. I've bored the class before with the Drake equation, but the Drake equation expresses in numerical probability the probability of finding life intelligent life on another planet. And if you plug in and guess for all these numbers, you crank it through and it gives you an estimate. Just like you can predict on a deck of cards, what's the odds of pulling out a three of spades?
1 in 52.
Yeah, yeah. You can use this equation with plug in those numbers and come up with a probability. Next slide.
So what did they come up with?
Um,
It's likely to.
oh yeah, absolutely. With the numbers, stars we've got.
Mhm.
Let's see if I've got a few notes. Next one down, next one down. Okay. So here's a little touch on probability in cards. So our galaxy, just our galaxy, and there's trillions of them, is estimated to have at least 100 billion stars and be at least 100,000 light years across. Now let's jump over to a deck of cards. The probability of being dealt a royal flush is, the odds are about 650,000 to 1. Okay? If the probability of the sun having a habitable planet is the same as being dealt a royal flush, I would say for each sun, let's assume the chances of there being intelligent life in that a planet on there is the same as being dealt a royal flush, then we probably have 155,000 planets in our galaxy that met this criteria. It just shows us the power of infinity. Yeah, about 80% of star systems are expected to have planets. The vast majority of the planets, 3 times the size of Earth or smaller. It's estimated there are approximately 60 billion rocky habitable zone planets in our galaxy alone. So if you've taken probability and statistics, you know, keep rolling these dice. We're gonna get some hits, especially with the building blocks there. Next one. Okay, now we get into aliens a bit. Can aliens get here? Travel limited to the speed of light. The nearest star to Earth is Proxima Centauri, and that's about 4.25 light years away. The fastest man-made object is NASA's Parker Solar Probe, and that may need to be updated. But it reached the top speed of just a fraction, not even 1,000th of the speed of light. The speed of this Parker Solar Probe made it up to 0.00064 the speed of light, not even 1,000th of light speed. And in space, here's an actual picture of a tiny paint chip that hit the one of the windscreens at one of the space shuttles and dented the windshield. And you say that wasn't going full orbital speed. It was going either slightly slower or in a retrograde orbit when it hit the windshield. They say if a tiny paint chip, hit with even half the speed of light or a quarter the speed of light, it would be like an atomic explosion and just destroy the spacecraft. So that's what makes traveling near the speed of light in a spacecraft so incredibly dangerous. You hit just a tiny fraction of a speck of sand and you're gone. So the limit of the inability to get above the speed of light and the consequence of hitting any kind of matter, even the tiniest one, at near even a fraction of light speed, puts so much kinetic energy into you, you're a goner. You remember kinetic energy, 1/2 mv squared? Kinetic energy is increases as the square of velocity. Okay. Which means getting in an auto accident at 60 miles an hour is a whole lot worse than getting in one. It's more than double the damage of getting in an auto accident at 30 miles an hour because of the rule, because of the square of velocity effect. So with space expanding and all the complex motion, navigating anywhere across the galaxy is enormously complex. There's no fixed point to kind of set your stellar navigation system to. The Milky Way's main stellar disk is approximately 100,000 light years across. So the biggest argument that Carl Sagan and many others have made is that the speed of light just limits the ability of a life form getting from one place to the other in millions of years. So that's maybe the most powerful argument against aliens visiting. Next one down. Okay. Aliens visiting the Earth. We see thousands of pictures of flashing lights, some flashing lights going across. And we see maybe what appears to be disk, but we never get a really good picture of an alien spaceship with crisp detail or something. That we have not come up with that.
The government hadn't released them yet.
Another thing Neil points out in his book, compared to 50 years ago, we now have millions of people carrying cameras on their purses and belts around. And we should be getting, if there's alien visits, encounters, we should start seeing a step up in the number of pictures. And we're not seeing that.
Ron,
yeah.
It's 11:15. Do you mind if I ask Spencer his opinion of aliens now? What the university thought is on?
Remember Zoom.
Yeah, you're on Zoom. UFOs and aliens. What's the thought currently, Spencer?
I think, I guess my current thoughts is that I don't believe that we've been visited. I think that, again, there's plenty of arguments that in today's era, we would be able to prove it, whether the government was hiding it or not, whatever.
Yeah.
I think something like that would just, be hard to kind of, cover up, basically, is what I'm thinking. So
What do you think these are that we're seeing that move in ways we haven't seen before? Are they secret military projects or?
I think, we have, these days, we have more and more satellites in the sky, secret military projects flying around. And I think the power of the human brain to, come up with reasons for things that we see is kind of extraordinary. So I think all of that contributes to, some of these events that we see.
Thank you, Spencer.
Great answer.
Yeah, and I think you get light from swamp gas. I know when PT boats were flying around the South Pacific during World War II, they would go through algae fields in the ocean at night and leave behind fluorescent trails.
That happens.
Yeah, there's a lot of explanations. Even laser beams bouncing off of maybe moisture in clouds, stuff like that. Oh.
One of the questions posed at for my students was about black holes. And is it pretty common knowledge that now there's a black hole at the center of every galaxy or universe?
I think that's the case. I think that's
students were always interested.
Right.
Can wormholes get you there faster than?
That's another one of the. Are there wormholes? Yeah.
Something that really interests me is what Nora was getting at, is our theology. Can we, as people of faith, can our theology keep up? To me, I look at universe with this much mind-boggling math and physics. To me, we are just beginning to comprehend it.
Yep.
We aren't inventing it. We are trying to comprehend it and understand it. How does our theology keep up with this? Obviously, ancient people, and our ancient scriptures, they couldn't keep up with it. How can we, adapt to a God or a force or whatever that has creativity and intelligence so far beyond our imagination? And how do we apply this to our lives? And how, just imagining a God like that, caring and loving, and it being involved in the lives of us. Why would that, how does our theology adjust to that? And I have been really encouraged by the work out of Yale on their Department of Religion and Ecology that has done some remarkable work with the journey of the universe, looking at all these different theologies and the way different religious beliefs have come to terms with modern science. And so that's a discussion I would just love to have more and more. I mean, you're just starting this discussion, but how theology and science can interact and make a difference in our lives, how we live, how we explain our faith to other people, and have it make sense. That is where I would love to see more discussion, kind of like how can we take this information and go with it?
That's another semester. For this stuff. Well, but yeah, it does make people wonder. Does this cosmic God need so many worshipers that he's got to create trillions of them? Do all these aliens need to be saved? Does Jesus need to go to visit all these places and be the atonement for all the aliens dead?
Do we as human beings who are conscious of this, do we have a role in this eternal thing? I mean, we talk about eternal life. Is such a thing possible? Is the energy that makes our human spirit something that is eternal? Could it travel? What is our purpose on this earth? Why are we alive? And does it interact with us all?
Something simple.
I'll let you know next week. I'll leave it on the
Dodge.
Okay, next slide. Yeah. But yeah, it blows the mind, and it does smack our theology hard.
I want to build on something that you and Spencer said about people and their beliefs and how things can be perceived or misperceived, as you guys are both suggesting. Some years ago, my colleagues and I hypnotized two young women who claimed to have been abducted by UFOs. And under hypnosis, they gave very interesting stories, sort of the classic stories about meeting aliens, going onto a spacecraft, being examined pleasantly, not sexually, and not being able to figure it out, being quite traumatized, and being released. These two women weren't lying. They were in a belief system which they had created. We felt that they were in some ways marginalized people who were struggling to find a place for themselves, but they weren't lying. But they also weren't abducted by a UFO.
Interesting.
I was just gonna add one thing to your comments back there. I said to someone in a hot springs pool in Glenwood Springs that science explains how, God explains why. He was very conservative Wisconsin Synod Lutheran, and he liked that. He thought that reconciled both.
Right.
Just a quick comment about Patty's question that our senior pastor, Rev Mark, has done several sermons that incorporate these kind of concepts like quantum entanglement. And he said, does that relate to God and us when two particles can be not seen, but we know they're in connection and they're communicating with each other? And is that kind of a clue that God does that with us? And so Mark has really delved into some of these too, if you want to go back and look at some of his previous sermons on this. Yeah, yeah, they're all recorded on YouTube. Uh-huh.
Okay. All right, where are we on the slides here?
Go back.
I think we're down to just
Here.
1, 2. So we're not getting that, we're getting a lot of weak evidence, but we're not getting any really striking, really grab you evidence, tangible objects.
The day the earth stood still.
Yeah. Yeah. Good movie, by the way.
This little screen is stuck. Here.
Okay. Yeah, again, there's excitement about the moons within our solar system in terms of several of them. Look very exciting, possibly having some, at least early life. Next one. Europa, Titan, and Enceladus look really exciting. NASA launched the Europa Clipper in October 2024 to go out and look at Europa. So that's a Jupiter moon. Next one. Okay, there's the theology questions. There are millions of aliens. Do any of them get to go to heaven? Are some aliens intrinsically morally superior to us? Do aliens have original sin? Maybe their Adam and Eve chose more morally. Does Jesus have to bring the gospel message to them? If aliens reproduce without sex, how can Jesus be born via virgin birth and dwell among them? Does Jesus have to atone for the aliens via sacrificial atonement? Does an advanced alien life form have a telepathic transmitted holy book equivalent? So yeah, it brings up a lot of wild stuff.
Well, and I don't understand why we have to use the same framework.
Yeah.
For other life forms. That's what we- I mean-
Exactly.
Okay. Why do we use this framework? Why do we think Earth is the standard that everyone else has to meet?
Right. Excellent. What was it? The rock group Kansas did the song Dust in the Wind, where all we are. Sometimes it feels that way. It really does. You say, well, if God cares as a personal God for each and every one of us, why did he create such a giant galaxy and multi-universe? He surely could have kept it a little more, a smaller field for the cows, So
Maybe it's a clue as to the vastness of God himself.
There you go.
Maybe it's showing us what he can do.
Yep.
Why are we
Maybe there are
asking all
some
those
things we're
questions of
supposed
all
to
the other beings on this planet, from insects to elephants to whatever? I mean, we're not asking those questions. Why are we asking it of aliens?
We've got 5 minutes left.
Go through the rest.
Yeah, I read where they've studied some of the more intelligent life forms, and the octopus has a central brain and then has a mini network brain on each of the arms. And they have found it works like a computer network. And they're also finding the octopus has a much higher intellect than we thought. They take revenge. They grab stuff out of their aquarium and throw it at light bulbs that are disturbing them. They try to escape.
And there's a current movie about that with Sally Field.
Yeah.
Yeah. Okay, Ron, do you want to go to questions, comments?
Yeah, let's do. Of course, my favorite, Marvin the Martian.
Okay. Okay, Ron's last slide says, what does this do for our theology? What's the connection?
Praying mantis.
Wow.
Praying mantis.
Okay, let's continue on the
Anybody, go ahead.
fire away.
What does it bring up? Laura Lee, go ahead.
I was just gonna say that, having heard as an atheist, unfortunately. My son's opinion is, why does there need to be God?
What else explains it?
But
No,
why
I
does that
see
God?
Einstein. I mean, the physics, the math, the physics, the math, the astonishing size of this. I mean, I don't care what word you use. It doesn't have to be the word God. It could be some other cosmic word that we haven't invented yet. But what else accounts for all of the whole universe, and then all the diversity of life on this planet? How it got here, how it evolved, how it came into this astonishing array, and and what accounts for us. Whatever you want to call it, there's something massively intelligent going on out there, and that we can be aware of it, or we can make fun of it, or we can discount it. We can live our lives in with it or without it in our own mind. And I think our minds are bigger when we think of intelligence beyond our own. That's why I think it makes sense to be a believer in God of some form than an atheist. To me, an atheist has a very limited field of, because they're not being able to comprehend that there's something way, way, way beyond that is generating this sense of wonder and awe that is possible in us.
Easier for them to ignore.
Well, like Einstein said, he thought there was some force out there that created this, but he didn't believe in a personal God similar to a human mind. So, and Carl Sagan said he didn't believe that there was a personal God. There's not enough evidence to believe it, but it still was very possible. So I like to think what the really smart guys think about it.
Einstein
Yeah.
used to say God doesn't play dice with the universe. So he was always looking for some unitary theory.
Unitary
He
theory.
never came up with it. And he took more time studying gravity than he did.
Trying to figure out God.
Yeah.
But he did say, right before the crash of the Depression, Einstein said that even as a Jew, that he was absolutely fascinated by the person of Jesus, the Nazarene.
Mhm.
He said, you look at the stories in the Bible, he says, I am fascinated by who that character was, and it had influenced his thinking. And that was published in right before the Depression, 1929. And there's something about faith that impacts a lot of scientists too. They find, I've read a lot of scientists who are saying there's something theological, something philosophical, something religious of magnitude or nature that explains some of this a whole lot better than science alone.
Francis Collins.
We've just got a minute or so left. If you don't mind, Spencer, I'm gonna ask you what your thought is on God, if you're comfortable. If you are comfortable. If you're not, just, it's okay.
Out of the room.
I think even in my limited years of experience in this world, there does seem to be kind of a flow of life, as I would call it. Like things are not predictable, I guess, but things seem to flow in a certain way if you kind of are looking for it, if you believe in that. And I think that there's many ways to interpret why things happen in life and why things seem to flow a certain way.
Yeah.
And there's just so many ways to look at why that happens, and I don't think it's something that you can really prove. So,
No.
If you feel it, then I think you should try and just trust your gut and go with that, and kind of hope that takes you to a positive, purposeful life that you can leave. I think that's all
Well
we can do.
Well said.
Thank you, Scott.
Okay.
Okay, any final thoughts? Okay, thank you, Ron, for a great presentation. Okay. All right, we'll see you next week with our guests. See ya.
Thank you,
Bye-bye,
Ron.
everybody.
Bye.
I know that black holes exist.